is what we're going to be doing today, and the more detailed packet has a lot more instruction on it for if you were to do surveying of a screen cross-section, which is what I'm under the impression everybody's here to learn today. Obviously, we're not in the middle of the stream, thank goodness for that, so we're not in waders and all sweating through that, but yeah. So today we're going to be locating 10 to 12 points that are shown on your maps that you each have between your groups. Of special note are that roof peak that's right up there. Obviously, you can't get up there, so you're going to have to plan out, and I'll help you plan out how you're going to determine the location and elevation of that. Another one that you may not, actually we have a perfect view for it right here. You see that antenna right there? That's on top of that facilities building, Building A, if you guys have ever been over there. I just ventured over there this morning when I was looking for something. We used to have a radio tower here, and they took it down for the new fitness center. So there's that. So we'll be locating the very top of that antenna. We're locating that light pole over there. So the second one down. That electric junction box up near the corner. There's a speed limit sign right there. We're doing the 4 corners of that foundation. Let's see. I think that's most, oh yes. And the culvert that's over there, that was the benchmark we used in surveying. We're going to find out today what the true elevation of that is, both the crown and the invert. So we're going to try to do this with a single setup, or as few setups of the total station each as we possibly can. I guess let's go ahead and start thinking about where we might want to set up these total stations so that you can kind of maximize that, the number of points that you can get per setup, because that's something that moving the setup takes a lot of time in the field. So being efficient, have a plan ahead of time. So you've arrived at your site, you know what points you wanted to get. Where do you think might be a good place to set up your total station at? Anyone? Once you've kind of figured out where you want your total station to be, we also need to determine, we have GPS units to absolutely determine our position. So we're going to have to figure out good locations for those as well. Sometimes you'll be very limited on space. I'm going to step back and not trip over that. So you also have to place your GPS units. You guys remember how those work from surveying? You use the Trimble, of course. So it works basically the same way as a Trimble, except that it's much more accurate. Basically, because we're putting it on a tripod somewhere, we're getting a signal from satellites that is then telling us the time it took to get there. So then we know by trilateration from multiple satellites what our position is. So bearing that in mind, any of that signal that gets reflected or is interfered with is going to cause bad GPS data. So we want, whenever we set up our GPS unit, to be, clear of all this tree cover as much as we can. We want to be away from trees. Sometimes you're stuck in a forest and it's the best you can do, but if that's the case, your detailed instructions will tell you to definitely let it run longer than that and to take many GPS points, not just one. Today, you're going to need 2 total GPS points to be able to absolutely fix your position, in addition to a compass bearing, or you can do 3. And you don't have to do this in one setup, but if you can, it's a lot faster if you can spend just a little time planning it. Of course, we don't want to spend 30 minutes planning it, because we could have done it 6 times by then, moving it around.
So guys, what is your reasoning for selecting this?
Well, we know we're going to have to go to 2 locations because it's just not possible with the tree covering to get all the spots in one, but we think right here we can get most of them up here, and then we'll move somewhere over there to get the 4 corners.
Okay.
All right, so you're planning to go out where he's buried that in the ground, where it's very far away from any of you guys being able to use it, as you're going to need it in a minute.
Yes.
So it's good to plan out where you're going. It might be a good thing to do with one of these, because you're going to need that in a minute.
I know, I
Okay. Yeah, all right, well, might want to take these chaining pins out. That's what they're there for, is to help you mark stuff in the field. We're going to put one underneath here. Once we're good and set up here, we're going to put another one where we're going to, wherever you guys decide to put your GPS unit, we're going to put that chaining pin down before you set it up so that you can sight it, because once we set up over it, you're not going to be able to get the pole over that point very well, and definitely not level. So that's the reasoning behind that.
Strategy always is to use two together and then one.
Oh, I always use two together. I've never done just one.
As in use two and
then one. Oh,
Yeah, so the two will send it either this way and then the one will send it this way.
I always heard use two at a time. I never heard use two at a time.
I've set it up and just
So then all you got to do, so you unscrew that and then squeeze these together and then pull it out. So you do it, Stigma.
Wait, I missed that step.
You just unscrew and then you squeeze those two together where you got the red tabs, and then it comes right out. Oh, there was one in it.
But now you know how to open it.
Yep.
Is that the battery?
So
Yeah.
so that's the battery. It's just like one of these. You
Come
just
here.
put it right back in there. So on the other side,
How do you know the battery is
turn it on. There you go. Always a good thing to see. So now comes the real test with the leveling. You got to satisfy the machine that it's level.
Oh, the battery is full.
Yes.
Well, when you get to grad
So
Yeah, look at
here,
it.
yeah, you got screens on both sides. They show the exact same thing.
Oh, okay. Yes.
Oh, it's the same thing on both sides. Okay.
Right. So then you've got your battery indicator up here. You'll have your horizontal angle, then your vertical, and that's your slope distance. We'll talk about horizontal and vertical in a minute. You guys, so then the horizontal, that's your angle. So if you turn that, you see how that's changing?
Yes.
Your vertical, see how that's changing? It's measured from here, that direction. If you flip it all the way around, you see how that is now, should be 200 something, or yeah.
Oh,
No,
the
yeah,
vertical
so the
one.
vertical.
Yeah.
So now you're in what's called back face. We don't want to shoot angles like that because it gets confusing. You're constantly subtracting 180. You don't want to do that. You always want to make sure you're in front face.
Okay.
So if it's more than 180, you see where you would be with 180.
Yeah.
You want to flip it
Okay.
around that axis.
Oh, so that is this vertical, right?
Yes, sir. This vertical right there.
Okay.
So right here, we're between the range 0 to 180 because it's measured from 0 being straight up.
Okay.
So then you're increasing. You hit 90 where you're horizontal. Then you go all the way through 180.
Okay.
And then when you come back this way, you're in back face. You don't want to be doing that.
Okay.
So let's go back the other direction.
Okay.
So it's
Sounds good.
No, just make sure it's your zero. Just like the way we draw the Cartesian coordinates, your zero being there.
Oh, I do notice that as soon as this is changed past 180, it became Roman numeral 2 as opposed to Roman numeral 1.
I actually hadn't noticed that before, so
Which one?
that's probably an indicator for exactly
yeah.
what we're talking about, most likely. I don't know that for a fact.
I don't know either, but something that I noticed. So, good.
So, yeah, so we have those. I need to give them theirs. So, we have, for short, we call it a gun, because you basically got a gun sight on it. So, looking at that, you guys already got the battery figured out, I trust.
Yeah.
If not, just unscrew that, pull that out, make sure that the contacts, the gold contacts go up. Anyway, so now that you got it set up in level, so you have these two little kind of cheater things up here. They have a little cross, a little white cross, that if you kind of look at it, you know, a little bit askance, you can kind of see that tells you where that optic is generally pointing. So when you're just fumbling around, if I want to look at the band tower, I'm kind of doing this number, I'm looking up here, I'm not looking down in the sight because I need to see everything. And then when I get close to where I want, then I can get up close on it. Then you have fine adjustments. So one is horizontal and one is vertical. You can turn them. and it will do that just a little slightly. So if you got big meaty hands like I do, you know, you're not fumbling it all over the place. You can get it exactly where you want to go, especially on long distances. All the way to 180, as you'd expect. And if we go the other way, it continues increasing. So now we're in back face. So if you see a vertical angle that's greater than 180, you need to flip your sight this way, because we just want to do them from 0 to 180. It just makes it a lot easier for later interpretation of what you did. And then this one will be the distance that we're shooting along. You see how it's sloped? It's a slope distance. So it's neither the horizontal or the vertical. It's the whatever the longest leg of a triangle is. I think it's the hypotenuse.
Yeah.
For some reason, I went for the word hypotenuse, and then it escaped me, and I said, no, that's not the right word. Anyway, the hypotenuse of the triangle. So there'll be other ways that we can do horizontal and vertical distances, just as those distances instead of angles, but some cases you'll need one, some cases you'll need the other. So now that you've got this set up, you got it good and level. So you're not quite level. So this is the leveling screen. So you've got.
How did we come to this screen? Because first when I saw you had a vertical and horizontal angle. How did you come to this screen?
So you guys can get between these by just pressing this enter, basically accepting that this is what you want and this is not what you want for the record. So then it brings you back to that. But then when you say, uh-oh, I need to get it back to level, look for the button that has a level and a laser on it. So that, I haven't showed you guys that yet. It's projecting a laser. See that on my hand there? So it goes all the way down, and that's the point that this instrument is set up over. So when we have to measure your height of instrument, that's what you need to measure to that point, from that laser right there to, and I'll show it on both sides so you can see it there, this circular dot right here.
So you have to measure the height of it.
Not to enter it here though, right? We don't have to.
You don't have to enter it here because we're not using a data collector.
Yep.
But so if you were just going to transfer a height or do something like that, you wouldn't need the height of instrument. But if you want to know what this point is or anything like that, you need it. And it's better just to go ahead and record it. In the field, when you don't know whether you should record it,
do it.
So we just use a measuring tape and like measure the distance from this point to the ground, straight
to
The
the laser.
But this is in the center. This is on the side.
Yeah.
Zooming.
So truly, we should have a plumb line out here and be doing it with that.
Yes.
It's one of those things that our department does not have those handy at the moment. So.
Yeah, I wanted to
Actually, there you go. Lock that. That way you can do
Then
that. So what we should do first is make sure you have it good and level. Because if this moves the height when you're leveling it, then that could change your HI. So make sure it's good and level first. Did I show you guys the trick on how to level that? I can't keep track of who I've shown what. So
you showed them the other
team. If I keep
team.
asking you that, I'm sorry. But so right now you have, you know, if I got it kind of askance like that, you know, these are doing, and it's changing things all over the place, right? We need a way to isolate that so that we can work with a simplified system. So turn it so that this plane down here is level with, or not level, but in line with one of these. So now these two control just the horizontal, and this one controls just the vertical. See how that works? So I can work with just these two. Well, I didn't get it quite, but you get the idea of how that should work. So go ahead and try doing that and get it good and level.
You're leveling what now? I'm getting a little confused.
So we're doing the entire instrument, but because we have 3 thumb screws, what we're doing is turning this such that only 2 of them control one of the directions and one of them controls the other. So that it makes it, a lot easier to do that rather than getting 3 exactly right.
Okay.
rotate, I guess. Okay, nice.
Oh, you went back.
After traveling, we need to rotate it and check.
Right, exactly. Yeah. Somebody's been reading.
So if it's in the middle, that means it's level.
That's good. Exactly. Just like if you had one of those physical
Turn it
levels, if it was
90
right
degrees.
in between the marks.
90 degrees.
Check.
And then check it again.
So we need.
It should be the same in both directions, because otherwise you've only got it level in this direction and it's still sloped that way.
And this bubble is just for the Leica base station.
This little mark right here.
No.
Oh, the bubble there. Yeah, it's just to get
Just
it
for
close, and then the digital is going to be a lot more precise than that bubble ever could be.
But how it's like angle, right?
Do the best to keep it as parallel as possible. The way I would do it is flip it.
This way.
Yeah.
And stand on the. You're your engineering professor, and it should be in the bottom.
All right.
Come on, Collins, hold it properly.
Okay, this is 0 feet. Okay.
There, yeah.
What's that? I can't see it again.
Here, it's here.
Oh, I'm getting old.
Okay. So that's it, right?
Yeah, that's it.
Tighten it. Here.
Slow just a little bit, then so then it's back here.
Yeah, you have to straight.
Yeah, Collins, move it just a little bit so it's relatively parallel. And you need to make it taut, Minhaj.
Yeah, you have to stretch
The
it.
dot button.
Stretch it.
Stretch it.
The
stretch it.
tape.
Oh, okay.
Make it tight.
Okay.
Do the best you can. What you got.
So it's 5 point.
Raise a lot of value.
067. Yeah. Because it's less than 5.1.
We're gonna sketch.
Is anybody noting it down, or are you just saying it for saying?
No.
He is so precise. I don't know how. 5.1.
Because it's less than 5.1.
Here, 3 figures. 5.1, 5.7, 5.0,
5.07. I guess this one.
5.07.
How they need to do a sketch of the area now that we've got it good and level. They've selected a point over there for their GPS to go. But before we set that up, we need to shoot that location because once
It's there. Yeah.
once we set the unit up, we're going to have a hard time getting a prism pole level
Yeah.
over it.
Yeah.
So we're going to do that and then
Put the GPS.
put the GPS over it.
Sounds good.
So you're confident that that's where it's pointed right now. The horizontal angle is what you want as your reference.
Yep.
Okay. So. you
So
see
we are
this?
doing angles then. We are doing angles, right?
Yes.
Okay.
We need horizontal angles, slope distance, and vertical angle,
yep.
or horizontal angle, horizontal distance, and vertical distance. So you see where this horizontal 0 is?
Yep.
So we're going to scroll down to here. So you see that horizontal 0? So you're telling it, this is where I want to be my horizontal 0, where I'm pointed right now.
Okay.
So you guys do it. So scroll down to that horizontal 0 button. And then when you're happy with it, press the red enter button that says, yes, I want this to be. It's going to confirm. Do you want to do this? Yes.
Okay.
And so now your horizontal angle is 0, right? So try turning it just a little to the right.
Okay.
So you see how the angle's increasing that direction. Now try turning it back to the center and then a little left of that. So you see how it's looped around, so it's increasing around going clockwise.
Did you take the orange thing, right?
Yeah, you're going to want to. You always want to go from one to that end.
Yeah, it's.
I don't understand, but you're free to do it however you want, as long as it works.
This is 0.
Right.
Tight.
Yep, make sure it's good and tight. So you save yourself some trouble. So you see this yellow screw here? You can release it, and then it's free to move. So you can set it at whatever you want. So I'm going to tighten it and let you do it.
So make it round then, 5 feet then.
Eye level is 5 feet.
Here, you might want to hold. Yeah, there you go.
Okay.
And if basically if you want to come around on the other side, they could probably use another set of hands, one to steady that while he gets that exactly
5
set.
feet. See? 5 feet. Just level it there.
Whoop. So you got to hold it steady so you don't lose height when he's tightening it.
Yeah, fine.
Yep.
And that tape is an engineer's, a surveyor's tape, so it's graduated in decimals, not in inches.
Yes, 5 feet.
Okay, so you guys got 5.00 feet then. So now that you know that, you know, so we'll know the point, the elevation of that point from the GPS. You know how far up to come to that optics, and then you'll be able to establish with your total station what the vertical distance is and what that horizontal distance is, so then you'll know what your elevation is with a reasonable amount of certainty. Does that make sense? So go ahead and line it up where it needs to go. Record your rod height if you didn't already.
Here?
On your sheet.
Okay.
And make sure that it doesn't change. And if it does, let us know immediately.
What's the rod height? 5 feet?
5 feet.
I think you guys chose 5 feet. Did you guys choose 5 feet as well? Okay.
That's okay. This one. Zoom in, then take EDM. Click on that disk button.
Center.
Okay.
Then we make the horizontal point 0.
Uh-huh.
And then shoot with EDM.
Uh-huh.
And then whatever we get there in horizontal and vertical, we
Uh-huh.
record it with that.
Okay.
target
And did he
length.
show you the difference between the slope distance and vertical angle and all that?
No, I guess.
Okay.
I wasn't
That's okay. That's okay. He doesn't know what I'm trying to
Maybe I
show.
missed it.
So, you see how you got a line at the bottom of this here? Snigdha, if you want to get closer to this. See how you got that line at the bottom of that? It's the triangle from there and then up and then a slope along there. So, that's that horizontal part of it. It's the horizontal distance.
Yes.
This one, you see how it's along the vertical, that's the vertical distance. So the other things that, what it's actually measuring, it's shifting, whoops. Let's go back that way. Okay, there we go. So now there's that vertical angle that we've seen before, right? That's that angle from here. It's measuring a slope distance, a distance at some angle, but it's the true distance from here to that prism, right?
Okay.
So it's just doing the trig for you
Okay.
to use the tangent to figure out what that horizontal and vertical distance are.
Okay.
So you can record either one. Just make sure that you record either both of these or both of those, and it's way easier in my opinion to work with horizontal and vertical distances, but there are some cases where you have to work with vertical angles. You're going to encounter that today.
So when you say you record either this or the slope, right?
Right.
So how we decide, like how we select the option? Just turn the page.
Yeah, so
Select the
so
page.
just shift page down, shift page up, and then page, so it's up and down. It's one of those that if you get into an unfamiliar menu, try shift page up or page down, and that will change that display. You see how you still have your horizontal angle in both of them, because you need that in both of them, but then it shows the other set of information that you could need.
So this one shows the distance, and what was the other one showing? Can you change?
So this one is showing the horizontal and the vertical, but if you now we've got that vertical angle from here this way and the slope distance.
Okay.
So that's the only difference. It conveys the same information, but in different ways.
Okay.
Why is the vertical this one negative?
So it's the distance from the center of this optics right here, where you measure your HI to the center of that prism.
Okay.
So what that means is that based on the way that you guys have got that set up, you had to go from here to there down 0.14 feet, whereas if you held it way up high in the sky, or you guys had set your rod height for 8, it would have been +3 or something like that.
Yeah, so the 8 minus the 5, for example, that would be good for
Right, right. And so you need
It's
the
all
rod height
triangles.
to know
It's all
exactly from the
triangles.
elevation of the ground up. Does that all make sense? Okay.
But why is horizontal not 0? Horizontal 0 is...
So then you've turned some from when you set the reference.
Oh, that's because
Yep, you've turned 7 minutes and 44 seconds. Somebody bumped it. But if that's what it's at, you know, if you're setting your backside here, then you could go ahead and zero it. But once you take other data, don't change your horizontal 0.
Oh, okay. So after I
You see how that would be a problem? Because you only know that position. You're only going to know those coordinates because of the GPS unit. So if you try to shoot on something else that you don't know the coordinates of, what's your reference to? You don't know anymore.
So I shouldn't zero it again.
Don't do it.
Don't zero it again.
Okay, so what next?
So now that we have that, we're going to shoot the other GPS unit because you need that second.
Because the
point,
horizontal
right?
angle
We're not
was
going to set our
moved.
horizontal zero on it,
because
but we are going to
time is
shoot it.
different.
So you're going to have an angle that's probably
So we are
340
repeating the
something.
same process.
Yeah, it's
And a
done.
horizontal distance that might be 1.5 times.
Alright, so they need to move the
Right,
put
exactly.
the prism there.
Yep, you got it. So let's make sure that everybody's got it written down first and has it on their sketch. You wrote down that horizontal angle,
Yes.
the distance and all that. So what that is saying is you back-sighted from there. So that is, this line is your zero. It turned 336 degrees around. So that's the angle that you've represented there. That's what that horizontal angle means. Does that make sense?
Yep.
Okay, so you're back-sighting, that's the reference. You're setting from the total station to there. That line is your 0 degree angle.
Yeah.
So then anything you turn from the right is increasing from that.
Okay.
So then the front sight is what you've turned to. So that way we can read back sight, where we've occupied, and front sight, and we determine in geometry A, B, C, that angle, because you need 3 points to determine an angle. That's all we're doing there, is writing down what those points are.
Okay.
Does that make sense?
Yep.
It'd be different from true north. If you guys remember magnetic declination and all that, because of the molten iron currents under the Earth's crust, that's what creates Earth's magnetic field, and they're constantly shifting, and they're not the same all the time. And so what was true north and magnetic north relationship at a particular point will vary over time. So you'll have to look up, if you're using this for anything more than a rough idea, because it could be off easily 20 degrees around here. So that's kind of settled. So north is roughly that direction. So on your sketch, you'll want to label a north arrow and put that it was magnetic north, because that'll help you, because we're going to get northings and eastings from those GPS values, so then you can graph that up, and then if you know what direction was north, you can determine based on your total station which of those two intersecting circles your total station was on. Does that make sense?
So
We're just going to take a few points somewhere, and then we're going to just probably try to do this roof peak up here just to get an elevation. We're going to forget about the antenna because that would require another setup. Spoiler alert. The way that you would do that is you would have a setup somewhere. You would determine its location with 2 GPS units, and then you would have another point that you were going to set up over, that you would determine the angle and the distance. You would determine the horizontal angle from looking at the antenna to that one. You move to the other point, look here, determine the angle there. You have 2 angles and you have the side here, so you can solve that triangle and find out what the position of that is.
Bottom, correct. And so we get the horizontal distance there, and then we would move and aim it to the very top, and so we have a triangle that's looking like that. We have the horizontal distance, and then we have this angle X, right? And then we can solve it just doing trig. Is that?
But what is the bottom of that triangle? How do you determine? So you have this distance, right?
Yeah.
But then how do you know that it's flat?
Oh.
okay, so in actual sense, from this device at 90 degrees, okay, the distance from this to the prism, when it's at 90 degrees, that's going to be the horizontal distance.
Okay,
You understand?
I'm with you.
So when you, how do I call it? When you tilt it vertically to capture the pinnacle of the roof, whichever angle you're going to get, if you deduct it from 90 degrees, it will give you the vertical angle between the horizontal distance and then the the pinnacle.
So, for posterity's sake.
So if you measure it this way,
Uh-huh.
all right,
Okay.
this is to the prism.
Right.
Now I have an angle that I took before
Uh-huh.
I got to the prism.
Right.
I know this horizontal distance. Now if I want to get to the top of the roof,
Uh-huh.
I sight it again, but this time it's with a different angle.
Uh-huh.
So using trig, just as he said,
Use
I
the
can-
traverse angles from each other.
I can find this vertical distance.
Okay.
And then if I want to know the elevation, knowing the elevation of this, I can add it and then.
Okay. Sounds like a plan. How they need to do a sketch of the area now that we've got it good and level. They've selected a point over there for their GPS to go. But before we set that up, we need to shoot that location because once
It's there. Yeah.
once we set the unit up, we're going to have a hard time getting a prism pole level
Yep.
over it.
Yeah.
So we're going to do that and then
Put the GPS.
put the GPS over it.
Sounds good.
So where do you think would be a good place to put your setup for your GPS units?
Except for the cloud cover.
Right.
Just put it somewhere in the middle.
Okay. And why would you not want to put it over there if the sun were beating down on us? You know, you work in the shade over there.
No, the tree, the satellite, it comes from different angles. So if there's one coming from that angle, we need to have at least a minimum of 3.
Exactly.
To triangulate. So
Exactly. You guys have got it. So you want an open space
Space, yeah.
to get the best signal you can get. Awesome. Alrighty. So I guess take one of your chain pins. That just unhooks right like that. And place it where you want your GPS unit to go. And then once you do that, it'll be a good time to take your engineering paper or whatever you have today and make a sketch of this area, kind of the building, the streets, stuff like that, anything important that you might be able to find on Google Maps later, stuff like that, so that you have a reference of what everything that you're going to write down means. Just label the points with short descriptive names, or I use total station, TS or GPS, things like that. And if you need to write a key somewhere off to the side, feel free to do that. All right, so we're gonna set this up over there. This is our Topcon Hyperlight GPS unit. Have a power cable for charging there. We have our power button to turn it on and off up in this corner. And this button, the function, will tell it whether you want to start recording and when you want to stop recording. So you don't want to run these without an antenna on. It could damage it. So all you got to do is just screw it onto the top there. So you screw that on, and then once that's good and snug, we'll put that on. This is called a tri-brack. It has a sight there that will show you where it's over. It also has thumb screws, just like the total station did. So we will screw this on. Collins, if you'll hold the tri-brack for me, please. You want to kind of keep a hand on it so it doesn't fall, because this is very expensive equipment.
Yes. Please be very careful, and also can be very delicate.
All right, so now that's good and set. So we would then put this on here and we would set it running. So what you're going to do is you're going to hold your power button until it comes on. See, we've got status there, it's blinking. We got our battery light up here. We got RX, which stands for
Receiving.
yeah, and then REC for recording. You notice that one's not lit up right now, it's not recording anything. So what I would do is I would hold this FN button once I've got it good and level and I'm happy with where it is, and it will start to activate. I'll hold it and I'll just release it. And then we write down what time we start. We need to get 30 minutes worth of data. And then when we're done, make sure that you hold FN long enough that it stops recording, because otherwise it's going to keep recording all the way home and you're going to have the trail of points all the way home and it's not going to be good. So basically that's the basic operation of one of these things. I'll show you how to get it on here real fast, but I'm going to take this one apart and let you guys put it together. While I'm doing that, we also have tapes that come in these that you can use to determine the height of instrument. You measure that to this yellow triangle, the bottom of this yellow triangle where it points down. And I'll show that to you guys more closely when we get up close with it, but Collins, go hold that tri-brack again, please. Again, to hold one way is to hold your hand here just loosely so it doesn't fly off.
Two are the same unit, right? That one.
Right, so they're essentially the same thing. If you were to do differential GPS, you'd have one that you'd leave here and one that you'd have on a pole like that you'd take around with you. You can use what's called differential GPS to kind of more accurately determine positions quickly, rather than having to have this over there for half an hour or more. One thing that's especially important here is that you do have some freedom horizontally with this. See how that goes that way? So then you would put this on here. Once you put it on there, if you don't have it completely locked down, this is free and you can turn it. So what you want to do is look into this sight here, and usually it's helpful to have somebody that kind of runs their hand down or wherever to figure out where you're at. You want to get it where the inner circle is over that point.
He'll explain that.
So you're probably going to have to move your tripod from where it is right now. Does that make sense? So another thing to consider, you guys look like you're decently level now, but also remember that at the end of the day, you're going to level this, and that's going to change the angle that it's pointed at too. So just take that into consideration, because that's going to change where on the ground that projects to. Does that make sense?
After the leveling.
After the leveling. So it's one of those things where it's much easier to just set it, get it level, and then put a point there. But if you have to shoot it with a total station, you're stuck doing it the other way around. We can't have our cake and eat it too. A bunch of these, right? We're not going to know which one was which. How are we going to know that? Well, there's serial numbers on a sticker on this side if you'll come around so we don't straddle the legs. But there's a sticker there that's got the model number and the serial number. Should be a 7-digit, 3, a dash, and a 4. And that's the serial number. So write that serial number down along with which GPS point that corresponds to. Hey everyone, thanks for watching. We made this video for the use of Tennessee Tech students, but wanted to share it with everyone just in case it was useful. While we didn't use any specific textbooks in the making of this video, there are several out there that would be great resources if you need them.